Let's go ahead and video homework number 3. Homework number 3. So definitely pull out your homework so that way you can go back. Your choice. I'm going to also take pictures of it, and you can just kind of go back and just look at the picture, grade your own paper, see how you did, or you can go ahead and watch the video, fast forward if you need to the sections that were kind of iffy for you. Okay, so let's take a look here. It says that finish writing the final double replacement reactions. Determine if they're an acid-base or precipitant reaction. If it's a precipitant, we'll identify the actual which one of the products is a precipitant. So let's go ahead and look. I've got lead and I got nitrate and I've got sodium and iodine. Now before I go any further, I can definitely tell that this is not going to be an acid base, because between those two compounds that are going to react with each other, both of them are not, or neither of them start off with a hydrogen. Remember, for it to be an acid base, we have to have a hydrogen there. So that's not going to work. Okay? So this is going to be some type of precipitant double replacement. So I'm going to go ahead and get my solubility chart out and ready, because I'm going to need that. What's going to happen is my lead here, Pb, is going to take the place of the sodium, because metal can only replace another metal. So before I go any further, I need to go back and double check and look at my oxidation numbers, right? Sodium, iodine, and 1 and a 1, they crisscross out. The lead over here, NO3, let me pull up my polyatomic chart. So NO3 is a -1 charge. The 2 crossed over, so we know metals are a positive charge, -1. Sodium is a +1 in group 1. Iodine is a -1. In that case, let's go ahead and let's look at, we can start off with our Pb, and it's going to start grouping up with iodine, because it took the sodium's place. Sodium, remember, metals are written first, it's going to go ahead and group with NO3, right? Before I go any further and write parentheses like it has over here, let's go back. Lead is my +2, iodine is my -1, Na is my +1, and NO3, which is nitrate, is in my polyatomics as a -1. Okay, so in that case, I'm going to go ahead and crisscross. 1 and 1 means do not put parentheses around it. And 1 over here, my 2 crosses over on this side. So my 2 comes down at the bottom. Next one, I'm going to come over here and I'm looking at my, because I know this is a precipitant, so I'm just going to go ahead and write that in. I'm going to pull out my solubility chart. It's on our formula chart. It's also in your notes all the way on the back. And I've got to look. So let me look for Na or NO3 over here. Na or NO3. Here's NO3, and I know it's really small to see, but if you've got your chart, you can see it. And it says that NO3 is going to be soluble no matter what, because there's no exceptions to the rule. He is going to be a liquid, or I'm going to go ahead and put it here in parentheses for you, an aqueous solution. There's no exceptions to the rule there. Obviously, my PBI, my lead and iodine are going to end up with, and I see it over here. Let's look. Iodine is soluble. That means that it's a liquid. It's going to be a liquid if it combines. But look, we have exceptions. What exceptions? If it combines with silver, Pb2, or mercury, Hg +2. And I've got a Pb with a +2 charge. Look at this, Pb with a +2 charge. So that was the exception to the rule. Iodine will become a precipitant if it bonds with Pb +2. And that is the precipitant there. Let's go ahead and look at this. I see that I have a hydrogen, which means that that's an acid. So over here, this is definitely going to be an acid base. Okay, so now let's go ahead and let's look at this. What was one of our rules, or going back to this one? Acid-base reactions. The products are going to produce water and salt, meaning that this hydrogen, which acts like a metal, I know he's not a metal, I know he's a non-metal, but he's in group 1 with the other metals. He is going to take the other metals' place. Remember, metals can swap with other metals. Even though hydrogen is a non-metal, he acts like a metal. So he is going to take that place. And when he does, this hydrogen is going to come over here with the OH. And what do we end up with? H2O. Look at that. So I know that hydrogen's in group 1. That's a +1 charge. My chlorine is a -1 charge in group 17. Magnesium is a metal, but magnesium is actually in group 2. So since it's a metal, it has a positive charge, +2. And OH is hydroxide, and that's in my polyatomics. Hydroxide is right here, a -1 charge, so -1. And you can see that when they crisscross, the 1 and the 1 comes down, the 1's over here, and this 2 came over here. All right, so now let's go ahead and let's do that. I'm going to have my H take the place of the OH, so H. And why did I write an O? I apologize. H, OH, because it moves over here with the polyatomic. And over here, magnesium, because he's the metal, goes first, Cl. Now, we have ionic bonding that's going on. What do? We have to crisscross. So H is a +1 charge, OH is a -1 charge, magnesium is a +2 charge, chlorine is a -1 charge. Crisscross, so there is no, you do not bring this little number 2 over here. Do not do that automatically. You have to still crisscross over here on the product side to see what's going to happen. This 2, though, is going to crisscross down here, so I'm going to put a little 2 by the chlorine. And I'm done. I don't need to worry about my solubility chart because there's not going to be, we're not worrying about precipitants here. I know it's an acid base. I'm done. Let's go over here to the next section. And the next section tells me that we're going to be doing some matching. So first one, a chemical reaction that involves the exchange of a positive ions between 2 compounds and produces either a precipitant, a gas, or a water. Okay. The key word here is 2 compounds. For an example, AB plus CD. 2 compounds are going to yield, and what is this going to be? A double replacement. C. Let's keep going. 2 or more substances combine, that's the key word here, to form a single product. So in that case, when they combine to form a single product, that's synthesis. 1 element replaces, oh, that's a key word, another compound. 1 element only, keyword single, so that's a single replacement. 1 compound breaks down, keyword decomposition. A chemical reaction occurs when a substance reacts with oxygen releasing energy, so there's energy involved. Oxygen is in the reactant side, and we're going to have some kind of energy, some kind of fire, right? Combustion, D. Alrighty, let's keep going. So, moving right along, we're going to be doing some, it looks like over here, balancing. So, let's definitely look at that. I want to double check our homework because this is homework number 3. And I might be wrong, but I wanted to make sure, yep, it is 1 page. So, when we're done with this side, we are done. So balance each of the following, then classify all of the types under everything. If it's a precipitant, circle the precipitant. So they want all things here. I'm going to go ahead and, as a reminder or as a shortcut, because if they want everything and it says all types of reactions that it falls under. So just kind of a short summary that we have in our notes. It was the last page with that little breakdown chart that it had. I'm going to go ahead and put is there a single element? And if you answer yes, we're going to come on this side. And if you answer no, if there's a single element somewhere over here on the reactant side, yes, then it's going to be what we call a redox because there's going to be ions involved. And if not, then it's going to be some type of double replacement. Now, don't forget though, we've got two types of double replacement. We've got acid-base, and we've got precipitate. Redox, though, there are 4 types of redox. We have it in our notes. We have combustion. We've got synthesis. We've got single replacement. And we've got decomposition. Okay, so we're going to need to make sure that we label those 4, 5, 6 things, and then if need be, redox also. That's what they're trying to say over here. I just wanted to kind of give you a reminder. Let's go ahead and I'm going to balance first. When I balance over here, let me draw my wall. I have iron and oxygen. 1 times 1 is 1, 1 times 2 is 2. 1 times 2 is 2, 1 times 3 is 3. Am I balanced? No, I'm not. Now, on this side, I need more iron and oxygen over here. So let me just start off with the irons and put a 2. 2 times 1 is a 2 now. So now I'm at a 2. Now, the irons are good except for the oxygen. Let me go and look at the oxygen. Now, before I go any further and put a number 2 over here, I can see that I have a 2 and a 3. If I put a 2, that's going to be 2 times 2 is 4. This is not going to be balanced. I can't multiply 3 times something to get 4. But I know that 2 and 3 have factors, okay? The lowest factor between them is going to be a 6, right? 2 times 3 is 6. 3 times 2 is 6. So we need to start thinking about that. Because if I do a 2 here, I'm going to have to keep on balancing and raising it a little bit higher. When that's not going to work, I start thinking about the factors between them. So I'm going to go ahead and multiply this side by a 3. And I'm going to have 3 times 2 is 6. I know that this is not balanced, so I need to come over here. But when I see that 3, I can go ahead and multiply 3 times 2, which makes this a 6. But because iron is attached, 2 times 2 is 4. That makes my iron on the reactant side not balanced. So instead of a 2 times 1, I'm going to have to do a 4 times 1, which now this is a 4. 4 and 4, check. 6 and 6, check. I am balanced. Now, do I have a single element? Yes, I do. So first thing is, this is going to be a redox. Now, what kind of redox is it? Combustion, synthesis, single replacement, or decomposition? Those 2 things are combining to one new thing. It's synthesis. Let's go to the next one and balance it. I have nickel and I have chlorine. Okay, let's multiply. 1 times 1 is 1. 1 times 2 is 2. 1 times 1 is 1. 1 times 2 is 2. Whoa, wait a minute. Rarely does this happen, but look at that. 1 and 1, 2 and 2. I am balanced. I'm going to go ahead and just put 1s there just so that way myself personally, I know that I balanced this equation. Actually, it was already balanced for me. Yay. Let's go ahead and go to, is there a single element? Now, when they ask you this question, they're asking you whether it is the reactant or the product side. Is there a single element? Yes, there is. It's over here on the product side, so that's okay. We still come to this side. This is going to be some type of redox because we have ions involved. Well, I have one thing and it breaks apart into 2, so this is decomposition. Let's go to the next one. I have lithium, iodine, lead, and nitrate. So I have a polyatomic, but look at this. My polyatomic stays bonded together on this side as well. So I'm going to consider the polyatomic as one substance by itself. So lithium, iodine, Pb for lead, and NO3. I'm going to draw my wall. 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1. And this is, remember, one whole substance together. So 1 times 2 is 2. Lithium, 1 times 1 is 1, 1 times 1 is 1, because there's no parentheses around it. Lead, 1 times 1 is 1, and iodine, 1 times 2 is 2. So I'm not balanced. I can see I need more iodine over here, so let me go ahead and put a 2. Now when I do it, the lithium is attached to it, so I need to remultiply. 2 times 1 is 2, 2 times 1 is 2. My iodines are good, but now it throws my lithiums and my nitrates out of whack, but that's okay, because I can put a 2 over here. 2 times 1 is 2 for lithium, check on that, and my nitrate, 2 times 1 is a 2, and let's check. 2 and 2, 2 and 2, 1 and 1, 2 and 2. I am balanced. I'm going to put 1s there. I am completely done. Let's go to look at our question. Is there a single element involved? No. Bonded, 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 bonded. No. So this is some type of double replacement. Is it an acid base? Well, let's go look at the reactant. Does something start with hydrogen? No. So this has to be a precipitant. So let me go ahead and write here. This is a double replacement. And what type of double replacement? Precipitant. Okay, so that means that we need to go ahead and look at our solubility chart. We're looking at the products, not the reactants. So on the product side, I got PB and I. So let's look for lead and iodine. Lead or iodine. Here's iodine. Iodine is going to be soluble, but there are some exceptions to the rule. If iodine is bonded with lead, PB2, which, let's come back over here. Is this a PB2? Remember, lead is a transition metal. So how do I know that it has what type of charge? This 2 right here originally came from this lead. So that is a +2 lead. So is this a PB2? Yes, it is. So instead of it being soluble, that means that it's insoluble or it's a solid. So in that case, my PBI over here is going to be my precipitant. Already done. Check. Let's move on to the next one. All right, next one. I need to balance it. CD, carbon, and oxygen. Draw my wall. 1 times 1 is 1. 1 times 1 is 1. 1 times 3 is 3. 1 times 1 is 1. 1 times 1, is 1. 1 times 1 is 1. 1 times 2 is 2. So 1 plus 2 is 3. So let's look. 1 and 1, 1 and 1, 3 and 3. What? Rarely do I get that, but I got it again. So I'm going to go ahead and put 1, 1, 1. It is already balanced. First question, is there a single element, whether on the product or the reactant side? Bonded, bonded, bonded. No. So it says here then, no. Then do we have a double replacement going on? Well, traditionally, this chart right here that is in our notes is a pretty good 90% of the time. It's going to always get you to the right spot. But in this case, I actually started with one object and broke apart into 2 different objects. Yes, I understand that I'm not ending up with a single one. So, no, I'm not ending with a single one here. But I am, and I'm sorry, I'm thinking about this for a second. CO2. So even though traditionally my chart helps me out, I'm not actually ending up with, a double replacement. Because a double replacement would be, I would have 2 things here and they're going to swap and switch. I don't have that. I have one thing that breaks into 2 things. But in this case, rather than having a single ion on the side, it broke the oxygens apart. 1 is here and 2 are over here. So this is actually a decomposition. It's not a redox because I don't have a single ion that's floating around by itself. It's just a decomposition. Okay, so that one was a little different. Sometimes, and you know that there's a lot of exceptions to the rules, just like our solubility chart, exceptions. So that one's an exception. Fill in the missing products, it says here, on the following reactants, and then classify the type. And if the precipitant is there, circle the precipitant as well. My goodness, they gave us a lot of information. And let's go ahead and do that. I've got chlorine, and I've got potassium, and I've got bromine. Well, what happens here is that my chlorine is going to, it's a non-metal, going to kick the bromine out of the way, and he's going to replace it with another non-metal, because non-metals can replace only non-metals. So the bromine's by himself, which is a diatomic, that's why the 2 is there, plus potassium gets written first because it's a metal, plus chlorine. Now I'm going to stop for a moment. We've got an ionic bond going here. So chlorine has a -1 charge. Yes, it's also a diatomic. Potassium is a +1 charge. So if I come over here, +1, -1, they crisscross. We do not need to add any subscripts over here, so we're good to go. Let me just double check. I've got, does it tell me anything about balancing? Fill in the missing products and classify it. It doesn't say anything about balancing. Okay, but I do see that I've got 2 bromines over here and I don't over here. So it would have to be balanced. So if I put a 2 on this side, that means that I've got 2 potassiums, 1 potassium. If I put a 2 here, that would be 2 and 2. So if I put a 2 here and a 2 here, oops, sorry, I meant to put it over here in front of the potassium. 2 here. Let me see. Chlorine, I have 2 chlorines. Potassiums, I've got 2. Bromines, I have 2. 2 bromines, 2 potassiums, 2 chlorines. I'm balanced now. I know it didn't ask to be balanced, but it is balanced now. Also, I don't understand why I have those, sorry, whichever direction or whatever you wrote it on. Is there a single element that's roaming around? Yes, there is. So it's a redox. And I don't care where you write it. I'm just going to put redox over here. And what type of redox? It's a single replacement. Let's go ahead and look at the next one. I have BaCl and silver and bromine. Well, the Ba is going to kick out the silver because metal can replace metal. And I see that I have 2 things here and 2 things here. So obviously this is some type of double replacement. Whether it's a acid base or precipitant, but it's a double replacement. I can look over here and see that it's not going to be an acid base because those reactants do not start with hydrogen. So let's go ahead and put BaBr, AgCl. Before I put little subscripts, let's go back and let's double check this. Silver is going to have if this is a 1 that comes over here, it's going to have a +1 charge. If this is a 1, it comes over here, it's going to have a -1 charge. This chlorine comes from the Ba, who has a +2 charge, and the Ba is the chlorine has a -1 charge. So now let's look over here. The Ba is a +2, Br is a -1, silver is a +1, and chlorine is a -1. Crisscross the ones. This one comes over here, but the bromine's going to have a little 2 behind it. Then, I know it doesn't say anything about balancing, but I'm just going to go ahead and look at it. 1 Ba, 1 Ba, 2 Brs, 1 Br. So if I put a 2 on this side, 2 Brs and 2 silvers, 2 silvers, 2 chlorines, and 1 Ba. Wow, I'm balanced now. So that's all I had to do to balance it. Once you start balancing more and more, it comes a little faster, a little easier. But since it's a double replacement and it's definitely not acid base, I'm going to go ahead and double check my solubility chart because there's probably one that's going to be a solid. Remember, we only look on the product side for this. And I've got Ba and Br. BABR. Okay, here's BR. And it tells me that BR is going to be soluble except if it's bonded with AG, PB, or HG. Nope. So it would be a solid if it was bonded with one of those. But since it's not bonded with one of those, then that means that it's going to be soluble or a liquid. I'm just going to come over here and put AQ for aqueous. Right? And then silver and chlorine. So let's look. Silver, chlorine, silver, chlorine, silver, chlorine, silver, chlorine. Chlorine is right here. And chlorine is going to be soluble or liquid in aqueous solution unless it's bonded with Ag, which is a +1. And my Ag has a +1 charge. Is my silver bonded to it? Yes, it is. Then that means that that's the exception to the rule. And this is my precipitant. And actually, on this side, you put a little S for a solid. Okay? So this is a precipitant double replacement. And let's look at the last one. I've got silver and I've got nitrate. I got potassium iodide. Silver, which is a metal, is going to take the potassium's place. So let's go ahead and let's write that in. A, G, and I, K, and NO3. I know that I have ionic bonding going on, so let me go ahead and let's look at this. Silver has a +1 charge. Nitrate has a -1 charge. That is on the polyatomics. Miss Munson, how do you know that that's a +1 charge? There's no parentheses around this polyatomic, so that means that there's an invisible number 1 right here. So that's the +1 when I crisscross back up. This is a metal, and he's in group 1, +1. Iodine is a -1. Okay? Crisscross, and look, 1 and 1. So when I come over here, I know honestly 1, 1, 1, 1. All of them are going to have 1s when they crisscross over. I don't have to do any kind of subscripts on that. But I do know that this is a double replacement. I definitely do not see any hydrogens on the reactant, so it's definitely not a acid base. I'm going to go ahead and come over here, and while I'm looking at the product side, let's look by any chance if any of them are going to be precipitants. So I have automatically, I see iodine, and here's iodine. Iodine is going to be soluble, meaning a liquid or an aqueous solution, unless it's bonded with silver, which is a +1 charge. Look at my silver, which is a +1 charge. That means because of that exception, this is going to be my solid right here. This is my aqueous solution over here. And so this is a precipitant reaction. I am done. So homework number 3 is done. I'm going to go ahead and take pictures for everybody, and I'm going to put those pictures up so that way you can look at your answers.